Happy day, everyone. This is Orekoya Olusegun, Physics Mathematics Fundamental on YouTube. Today, we are taking a topic regarding Kirchoff's law under electric circuits. Now, there are two Kirchoff's law. We have what is called the current law, and we have what is called the voltage law. But before we go into describing the two laws, I want us to have an idea of what is called voltage rise, voltage rise. That means increment in voltage, and voltage drop. That is a decrease in voltage drop. Let's say we have this particular resistor. Resistor R, and then there is a connection of this particular cell to this resistor R. If the current flow in this direction from the positive terminal to the negative terminal, the current will flow from the positive to the negative. So this positive we have here, we can equally put it here. This negative we have on this cell, we can equally put it here. So if the current flow from this positive terminal, it will go like this. So this will be the current I. So the current is flowing from the positive to negative. Therefore, we say the voltage is dropped across this resistor R. Voltage drop across the resistor R. In another situation, let's say we still have the same arrangement of resistor, but in this case, we have the cell in this case too, the way it is, but we now assume that instead of the current to flow from the positive terminal to the negative terminal, let's say the current is now flowing in the opposite direction, that is from the negative to the positive terminal. So I have this minus here, then I have this plus here. You can see that the current is moving from the negative to the positive. That means from the lower to the upper side. So we call this place voltage rise. So in summary, if I have a resistor R and I have plus, I have minus, and if the current is flowing from positive side of the resistor to the negative side, that is voltage drop. And if I still have the same resistor R and the currents flow from the current flow from the negative, the current flow from the negative, this current I, instead of, in the first instance, this current I flow from positive to negative. Let's say current I flow from negative terminal to the positive terminal. We say voltage rise. So this idea of voltage drop and voltage rise is necessary in solving exercise under Kirchoff's law. Now let's move down to the current Kirchoff's current law. The current says that the current law says that at a junction, let's say this junction is this dot, if the current is entering, I call it I1, that is entering this junction, another current I2 is also entering. This current here, I3, is leaving the junction. Now the current law says that the summation of currents entering a junction in a closed electric circuit, that is total electric current entering a junction, must be equal to the summation of electric currents leaving that junction. So what am I saying? In this diagram here, I1 is entering the junction, so plus I2 that is entering the junction, I2 is equal to I3 that is leaving that junction. And if I take this I3 here, I have I1 plus I3 plus I2 minus I3 is equal to 0. This arrangement I have is the algebraic sum. That means algebraic sum of currents at a junction must be equal to 0. That is the Kirchoff's current law. For Kirchoff's voltage law, let's say I have this particular cell here. So this is the positive terminal and this is the negative terminal. So the electromotive force from the cell, call it E. Now let's say I have resistor R1 connected, then I have resistor R2 also connected, and then the arrangement is connected to this cell in this format. Now if you look at this particular place, if the current is leaving this positive terminal of this cell, let's call it current I that is leaving, is moving from the positive. So this positive is connected to this R1, so this will be plus and this place will be minus. The same thing with this, as the current is moving around, this is a plus and this is minus. So the current is said to be dropped because it's moving from the positive terminal of this resistor to the negative. And then the same way, when the current moves here too, it's moving from positive to negative. But here the current is moving from the negative to positive. So because the current is moving from negative to positive in this cell, before it's emerge out, we say there is voltage rise. That will be positive electromotive force, then minus the voltage across resistor R1, call it V1, then minus the voltage across resistor R2, call it V2. The Kirchoff's law says in this particular closed circuit, the sum of the voltage in a circuit, the algebraic sum of the voltage in a circuit must be equal to 0. So, and also the total electromotive force in a circuit is equal to the total voltage drop. So if you carry these two to this other side, it becomes positive. So total electromotive force in a closed circuit must be equal to the total voltage drop in that circuit. These are the two laws of Kirchoff's. Please kindly remember to like, subscribe and share my video. I will now use this law to solve a problem soon. Thank you so much. Have a nice day. Bye.